All right, welcome to Unit 3, and this unit is about polynomials. We are going to be factoring, we're going to be expanding polynomials, but before we do those, we are going to be looking at the greatest common factor and the least common multiple. So before we look at those, we are going to look at some definitions. First, prime number. So if you recall, prime number is a whole number that has exactly two factors, namely 1 and itself. So for example, number 5, it would be a prime number because it has two factors, one being 1 and the other one is a 5. Recall, a factor is a number that could be divided evenly. So that's what a factor is, okay? Composite number, here it says a number greater than 1 that has a divisor other than 1 or itself. Essentially, if it's not a prime, then it's a composite number. Okay, if it's not a prime, then it's a composite number. Except, of course, again, it says a number has to be greater than 1, which means the numbers 0 and 1 are neither prime nor composite. Okay, 0 or 1 are neither prime nor composite. So prime numbers starts at 2. Okay, that's the smallest prime number. 2, 3, 5, 7, 11, and so on. Okay, so let's see here. It says, which of the following are composite numbers? Okay, so you can see composite number, remember, if it's not a prime, then it is a composite number. 5 is a prime number, therefore it's not a composite. 20 is a composite number because it has a factor 4, 2, 5, and so on. Okay, so it has more than two factors. 32 is a composite number. 21 is a composite number because, for 32, 4 goes into 32 evenly, so that's a factor, and that's not 1 over 32. So is 21. Okay, 21, 3 can go into 21 evenly, so that is a composite number. 31 is a prime, and 5 is a prime. Okay, so that's what a prime number is. We are going to use that in a second. And we're going to jump right into the first part of the lesson, the greatest common factor. Okay, so greatest common factor, by definition, it is the largest number that divides each of the given numbers evenly. Okay, so usually, well, there's at least two numbers, right? Sometimes could be more than two. But if you want to have a common factor, that means you're looking at a common factor between two or more numbers. So, but the greatest means the largest, right? So we're looking for the biggest factor out of the 2 or 3 or 4 numbers. So here's the example. It says find a GCF, the greatest common factor, of 36 and 60. Now I'm going to show you two different methods. The first one is using prime factors, okay? So recall, we could use, well, we did factor tree in Math 8. So factor tree, here's 36. 36 can be divided by 6. So it's broken into 6 times 6. And then 6 could be 3 times 2 or 2 times 3. Same thing here, 6 is 2 times 3. Therefore, you can rewrite 36 as 2 squared times 3 squared. Right? You have 2 2's and then 2 3's. And you're going to be doing the same thing for 60. 60 is 6 times 10, which then can be broken into 2 times 3 and 2 times 5. So 60 is equal to 2 2's, so 2 squared times 1 3 times 1 5. So the greatest common factor is simply you look at these two and you look for what they have in common, okay? So for 36, there's 2 squared. In 60, there's also 2 squared. So the greatest common factor is going to be 2 squared times, well, in 36, there is also 3 squared, but in 60, there is only 1 3. So what they have in common is one single 3, okay? Not 2 3's, just 1. Now there is a 5 here, but there isn't a 5 in 36 as a factor, so then we don't include 5, and therefore this is your GCF. So 2 squared is 4, 4 times 3 is 12. So the greatest common factor between 36 and 60 is 12. Okay, so this is one of the methods, and I will show you the other method. Okay, so this is the continuous division. This method is the one I used when I learned first when I was in elementary school actually. So I'll show you. 36 and 60. Okay. So essentially what you have to do is you just think about factors of 36 and 60. So I know 6 goes into both 36 and 60. 6 times 6 is 36. 6 times 10 is 36. And then you are going to continue. What goes into both 6 and 10? Well, 2 does go into 6 and 2 goes into 10 as well. So 2 goes into 6 3 times and 2 goes into 10 5 times. So we end up with 3 and 5, which we cannot find another common factor between 3 and 5. So the GCF is going to be 6 times 2, which is 12. And you can see both methods yield the same answer. Okay, so it doesn't really matter which method you use. Both are valid, and so both are useful, really. Because the first method, I know it seems longer, but that's actually the method I learned, or not I learned, but I use in university. So I think there's a valid reason to use both. So, just choose the one you prefer. Okay, I will show you another example, and I'll show you both methods as well. Okay, this one is the GCF of now 3 different numbers. Okay, so I'll show you by prime factorization first. 18 is the same thing as 6 times 3, which 6 can be broken into 2 times 3. Okay, so 18 is 2 times 3 squared. We also have 24 and 48. Okay, so for 24, this is 6 times 4, and 6 is 2 times 3, 4 is 2 times 2. So we have 3 2's, so 2 cubed times a 3. Finally, 48, we have 8 times 6 is 48. 8 is 4 times 2, and 4 is 2 times 2. So now the tree is getting bigger, so I would actually circle the numbers at the end of each branch so I don't miscount. 48 is 2 to the power 4 times 3. And therefore, again, GCF, once you have this lined up like this nicely, then it's actually easy to tell what you have or what they have in common. All 3 numbers has a 2, and all 3 numbers has a 3, right? Some of them has more than 1 2, but not all of them, right? So you gotta look for what they have in common. So 2 times 3 is 6, and that is the greatest common factor. You could also do it by continuous division method. However, if there are 3 numbers or more, there's a little trick, I think. Okay, so I'll show you. So both, actually, I'm going to start with a 2, okay? Because all numbers are even, therefore I know 2 will go into all of them, okay? So 2 times 9, 2 times 12, 2 times 24. And now that's 9, 12, and 24. So I know 3 goes into all 3 numbers. 3, 4, and 8. Actually, okay, so never mind. For GCF, there is no special case. It's for LCM. I'll show you in a bit. And nothing goes into all 3 anymore. And therefore, for GCF, it's just 2 times 3. So these 2 numbers, which is 6. Okay, these 3 numbers are a bit smaller, so it's not that bad. When the numbers are big like this, I think it's easier if you use the continuous division. Anyways, you can choose which method you like and give it a try. Good luck, and I'll show you the answer in a bit. Okay, so I did the prime factorizations here for 128, 64, and 200, and that's what you get. So what they have in common is that all 3 numbers has 3 2's, so 2 cubed, and that is it, because only the last number, 200, has a factor of the 5, but none other ones have 5 as their factor, so 2 to the 3 is just 8. If you use the continuous division, again, you can just start with a 2 because all 3 numbers are even. And then after you divide it by 2, you still can see all 3 numbers are still even, so you can continue to divide it by 2. They are all still even, continue to divide it by 2, and now 25 is no longer even, you cannot divide it by 2, and there is not another factor among those 3 numbers, and therefore your GCF is just 2 times 2 times 2, which is 8. Okay, so there you go. So hopefully GCF is not that bad. You can again use either method, and they're both okay. Now we're going to move on to the least common multiple. So just quickly recall, multiple is simply just the product of a number and a whole number. So when you multiply two numbers, like 16 would be a multiple of 2 because it's just 2 times 8, right? 10 would be a multiple of 2 or a 5 because 5 times 2 is 10, 2 times 5 is 10, so that's a multiple. Least common multiple then would be the smallest common non-zero multiple of 2 or more whole numbers, or the smallest number that is divisible by all the numbers. So essentially, you're looking for there are different methods. Okay, you can list out all their multiples. For example, like the multiples of 2 will be 2, 4, 6, 8. I almost missed out the 8. 10, 12, and so on. And the multiples of 4, actually, let's use 5 instead. 5 would be 5, 10, 15, 20, and so on. So the least common multiple would be 10, okay, because that's what they have in common, and that's the smallest, right? Because both of these are multiples, or sorry, 10 is a multiple of both 2 and 5, and 10 is the smallest, okay? So that's what the least common multiple is. So this definitely is a valid method as well, right? You can just write out all their multiples and just look for the smallest. Now that's definitely, one way of doing things. Now I will show you again 2 different methods, but not this one. Oh, actually, so in that case, I show you 3 different methods. I will show you by using continuous division and prime factorization as well. Now let me show you by prime factorization first. So 12 is the same thing as 6 times 2, which is 2 times 3. Okay, so 12 is 2 squared times 3. 8 is 4 times 2, which is then 2 times 2 for the 4. So 8 is 2 to the power of 3. So LCM. Okay, LCM is a little bit tricky. Okay, so it's a little bit different. Because GCF, it's kind of makes sense because you're looking for the common factor. So you look for what they have in common. Whereas for LCM, you're looking for what they have, what they all have, but then it's the biggest exponent actually, okay? Because you want to make sure you cover everything. So in this case, it is going to be, so you look at the 2 first, okay? There's 2 squared and there's 2 cubed. So in order to cover everything, because you want a common multiple, to cover everything, you gotta have 2 to the power 3. And then there's 1, 3 here. There's no 3, but again, you gotta look for what they have at most. So in this case, 1, 3. So this is going to be 2 times 2 to the power of 3, which is 8. 8 times 3 is 24, okay? So again, this is less intuitive because you are, even though it's the least common multiple, but you're looking for the highest or the biggest exponent for each factor, okay? So it's kind of tricky. Okay, continuous division, similarly, like what we did earlier, 12 and 8. I'm just going to do it divided by 2, so that's 6, and that's a 4, divided by 2 again, that's a 3, and that's a 2. And because it's LCM, you're actually, you're going to multiply everything here. So it looks like an L, right? There's L. So 2 times 2 times 3 times 2, which is also 24. Okay? So hopefully that makes sense to you. I will show you another example, this time with 3 numbers, okay? So we have 35, 60, and 75. I'll show you both methods, and then again, you can choose whichever one you prefer. I will do prime factorization first. 35 is just 7 times 5. 60 is 12 times 5, which is going to be 6 times 2, which is 2 times 3 here. And 75 is 25 times 3, and 25 is 5 times 5. Okay, so if I rewrite them as a product, so 35 is 5 times 7, 60 is 2 squared times 3 times 5. Okay, and 75 is going to be 3 times 5 squared. So again, LCM, you gotta make sure you include every single factor and you take the biggest exponent out of those. Now you can see out of these factors, you have the 2's, and then you have 3, 1, 3 each, so then the biggest exponent is just 1. You have 5 in each one of them, but the biggest exponent is a 2, so it's going to be 5 squared, and there's a 7. Okay, and now we just need to multiply this in, and I believe this is going to be 2100. Okay, so it's a large number. It's a large number. So, you know, like in this case, writing out their multiples, like if you do it this way, that probably is not a good idea, right? Because it'll take a while to get there. Okay, so this is the prime factorization method. I will show you by the continuous division method. Okay, so this is the one there is some sort of not interesting, it's just a little tweak that you need to watch out for. Okay, so 35 divided by 5 is 7, 60 divided by 5 is 12, 75 divided by 5 is 15. Now for GCF, we would stop right here because nothing else goes into all three numbers, 7, 12, and 15. So we would stop right here. However, for LCM, you cannot stop right here, okay? You actually need to continue because there's a common factor between 12 and 15, okay? So this is only true if you're looking for LCM, okay? So that's what continuous division, you just gotta be a little bit careful with the methods because there's some kind of special cases, okay? If you have more than 2 numbers, then you gotta watch out for this. Okay, now 3 does not go into 7, so just leave it like that. 3 goes into 12 4 times, and 3 goes into 15 5 times. Now you can see that's 7, that's 4, and that's 5. There is no more common factor among those 3 numbers, right? Or even just 2 of them. So therefore, you would stop right here, and then you can look for your LCM. And again, that is just a multiple of these numbers. So that's 5 times 3 times 7 times 4 times 5, which also gives you 2100. Okay, so just be careful if you decided to use continuous division method. When you look for LCM, you gotta be careful with this situation. Okay, so there's the last practice question for you to try, and good luck. I'll show you in a bit. All right, so here we go. I did a prime factorization here. So LCM, again, you look for the biggest exponent for each of the factors. So it's going to be 2 to the 4 times 3 squared times 1, 5. And this, I actually don't know what this is, 8720? Let me just double check with the calculator. That's 16 times 5, so 80 times 9, yes. Okay, now if you do it by continuous division, again, all 3 numbers are even numbers, so I can divide it by 2. And still even, I can continue to divide it by 2. Now, there's no more factor for all 3, but there is a factor for both 9 and 12, which is 3, so I'm going to do that, but you keep the 5 there. 3 times 3 is 9, 3 times 4 is 12, and that's 3, 4, 5. There's no more factor among those 3 numbers, and therefore you can find LCM by multiplying all these numbers together. That's 2 times 2 times 3 times 5, 3 and 4. And this should be, 720. That's 4. That's 15, and that's 12. So that's 60 times 12, which is definitely 720. All right, perfect. That's the lesson. Hopefully it's not too bad to figure out what the GCF is or what the LCM is, okay? There are, again, 2 different methods that you can choose. I don't really mind whichever method you use. As long as you can get it, it's all good, all right? Now it's your turn to do some practice. Let me know if you need some help, okay? Good luck.